Welcome to Unite Now, where we bring unity to you, wherever you are.
Hello everyone and welcome to Unite Now. I'm Chema Damak, a technical evangelist at Unity, and in this session I'll be covering how to use the device simulator to improve your user interface and make it more adaptive with the least iteration possible. So let's get started. Preparing and integrating a user interface, especially for mobile games, is getting very difficult to test on all devices that are released to market each year. We are witnessing a big boom in technology and thus different resolutions to be aware of. So, if you are creating a game for mobile and trying to have the perfect user experience, you'd need to think about the testing phase and spend a lot of time building on various devices. At least, that's what we needed to do before Device Simulator. Today I will show you how this feature works. To do so, we are going to adjust a simple user interface for a fictional game. This will be composed of 5 different parts: the player information, the buttons, the inventory, the friends list, and the score of the game. We will be using some cool UI from the Ultimate Clean GUI from the Asset Store, applied to a scene from the karting microgame project available on Unity Learning. Let's move to the editor. We've already prepared the scene, and as you can see, the user interface is exactly the same as the one we have in our mockup. Only problem here is that once we change the resolution, we'll notice that for some, the UI does not follow. In addition to the resolution provided by the game window, we can manually add our own. As you can see, these values do not work either. And if you have a larger pool of target devices, you might need to add more values to the list. Or better yet, you can test it with the device simulator. The device simulator package is available in the package manager. If you are working on Unity 2019.3 or above, go to the package manager. Be sure that you are enabling the preview package and download your package. Once this is done, you can find your simulator in the window menu under General or directly from the game window. And that's it. Better than building to see how it looks like on a device, just go to the list of provided devices and switch to your target device. This will not only allow you to check your resolution, but also, if you need specification about the phone or tablet itself, you can find in the device specification section some information about the operating system, the CPU, and the GPU. Let's have a quick glance at the other things the device simulator will help us do. To test our UI when the device is flipped, we can use the rotate button in the simulator view and choose the rotation direction to check our UI on. If your game, like ours, will only be played on a particular orientation, you can specify that directly in the screen settings and uncheck the orientation that will not be used. The screen settings from the device simulator will not tamper with your project settings. If you want to have them reflected in your final build, please make sure to apply them in the project settings window. Finally, the last section of the device simulator lists all the application settings you might need to test without having to switch them on your device. These custom values will be returned by the application API. For example, if your game is intended to be displayed with different languages, depending on the system language of the operating system it's running on, you might want to check all the languages implemented and how they react with the UI you have created. Also, if your game is depending on internet reachability and have different states between local area network, carrier data network, or no network, you can easily simulate these states directly from the editor. A button is also available to simulate a low memory event. This event normally occurs when an iOS or Android device notifies you of low memory while the app is running in the foreground. Now it can be reproduced by a simple click on this button. If you need a custom device or one that has not been added yet, you can easily create your own. Just go to the Package Manager, Device Simulator package, and you'll find a link to the documentation to help you create your own device. You can either create it with extended information or just the basic ones. Then, to add it to the list, open the Preferences and go to Device Simulator and link the folder in the device directory field. Now, let's go back to our UI. We've requested more information about the UI from the artist, so we could have it following the screen. They asked to have the avatar being in the top left of the screen, the score in the top right, having the button in the left center, and the inventory and the friends list taking a percentage of the height and the width. We'll do just that. Before starting, we will check the scaling method that we are using for this canvas. It will rescale with the screen with a reference resolution that we have set to 1920 by 1080. Second, we're moving to the player panel. We will need to anchor it to the top left of the screen. And because we want the calculation of the distance to be made from the pivot of the top left of the panel to the anchor on the top left of the parent, we will change the pivot to 0 on X and 1 on Y. This can be made either in the rect transform or in the scene directly. It will ensure us that whatever the resolution is, this panel will always be anchored in the top left with a distance of -30 pixels from the top and 30 from the left. So let's test this. Now to the buttons. We'll need them to be positioned compared to the center left anchor, so we'll do the same. We change the pivot and the anchoring, and then we put the new values. Awesome! Now the friends list. The artist specifically needed the list to cover a certain percentage of the screen. To change the anchoring, we could do it on the scene, dragging them and reading the percentage, or for more accurate values, we can do so in the rect transform component. Know that these values need to go from 0 to 1, 0 on X being the first point in the left of the screen and 1 being the last point in the far right. That means that to follow the logic of the artist, we need this panel to end at 0.98 on the X and start 30% before that, so 0.68. Same for the height, starting from 0 on the Y, ending with 0.85. Let's test this now. And it's working just fine. Same thing is done to the inventory, and even though we don't see any difference for this one, we know that the artist's wishes have been respected. Final element, the score. Let's anchor it to the top right. Now that all our elements are properly anchored, let's test them with the device simulator. It works perfectly resolution-wise, but on this device, the buttons are not properly displayed. Smartphone and tablets nowadays present a new challenge for everyone: the notches and edges. That means that if we want to have an element of the UI in one of the corners or in one of the borders, we need to take in consideration the safe area. Let's get some help from the device simulator. To visualize the safe area, we click on the button Safe Area, and a border will be drawn in the screen. You can change the color and the width of the border in the Preferences under Device Simulator. To see this change, we need to reload the Device Simulator window. Okay, now that we can see it, we can take care of the issue with one of two methods. Either we decide that nothing exists outside of the safe area, so we uncheck the full screen toggle and nothing is rendered outside of the borders, not even the game itself. To see that reflected in the final build, make sure to change it in the player preferences. Or the second method would be to create a script that renders our UI just inside the safe area zone. The script you create can be as simple or as complex as your UI is. For this project, we will use the second method and create our own script, the safe area setter. Let's create an empty panel that will act as the panel safe area and create and add our script to it. We will use the Screen API and get the safe area of the screen in pixels with screen.safeArea. Once we have this rect, we will convert it into values that can be assigned to our panel's anchor. To do so, we get the position of the safe area as the minimum anchor and the position plus the size as the maximum anchor. Then we normalize these values following the canvas resolution. Let's assign these new values to our panel. Finally, we make sure the script is updating the anchors each time the rotation or the resolution is changing during runtime. And of course, since we are using a canvas to normalize our anchors values, we need to assign this canvas. Now let's test this. When we enter play mode, we will see that the panel that we have will rescale to follow the safe area. Whenever we change the resolution or the rotation, the panel will follow. Now that we are satisfied with the result, we can drag and drop the other panels we have as child to the safe area panel. These elements will now adjust to the panel the same way they were adjusting to the canvas. Let's try this again in play mode and test on other devices. With the safe area now secured, we can move to the other part of the UI, such as the friends list. To test this feature, we need to manually fill it or create a script to do so. Let's look for the prefab that we need to use, drag and drop it, duplicate it, and click on the play button to preview it. Scroll down. Yes, it's working. Now, before building, we will need to remove all the added prefabs and the testing scripts. This makes the testing phase very long and strenuous, especially if you have multiple scenarios and need to test your user experience for different cases. As an example, let's take a look at what our artists requested. For the friends list, they want to implement different states. One where the list is filled, one where the list don't have any connected friends, and another one where the player don't have any internet connection. In order to test this scenario in the most accurate way possible, we are using the Random User Generator API to get real-life information for a list of users. As for the script to show these information on screen, it's the same that will be used in the final build and no additional scripting has been added. So let's figure out how to use the device simulator in this case. Of course, for network reachability, it's easy to reproduce. We already have it in the application settings. For the other cases, we are going to create our own scenario to extend the device simulator window. To do so, we are going to use the UI Toolkit framework, download the UI Builder package, create a UI for our specific scenario with a title and an integer field, and create a script to extend the device simulator. Let's start with the UI Builder. To download the package, we open the package manager and make sure we are still enabling the preview packages. The UI Toolkit, formerly known as UI Elements, is a built-in verified package that is already available in our project. Now let's open the UI Builder window and create a user interface to extend the editor. We save our UI document as a UXML file that we will store in the resources so it's easier to access. We need a title and an input field. Let's change their names so we could access them via code. And choose the labels that will be displayed. Now that we have all we need, we will create the script that will extend it and call it Device Simulator Extension. First thing we are going to do is implement the iDevice Simulator Extension interface. For that, we need to be using the namespace unity.devicesimulator. Also, and because this interface and this script are using the UI elements namespaces, we are going to go ahead and add them. Then, because it's an interface, we need to also implement the extended title variable that returns the title of the extension, and the onExtendDeviceSimulator method that takes as parameter the initial visual element our UI will be added to. If we go back to our device simulator window and wait for the script to recompile, we'll see that a foldout has been added to this view with the name that we assigned to it. Now, let's populate this foldout. What we're going to do, without going too much into details, is getting the UI from the UXML file we've created earlier as a visual tree asset and clone it to the visual element we created. We then look for the integer field we will get the friends count from. Then we search in our scene for the friends list script that takes care of the logic behind the friends list. Once we have all the components needed, we register a callback to the integer field and state that each time this value changes, the list is repopulated. Finally, we initialize this field and then add the UI to the initial visual element. Now, let's go back to the editor. After the script recompile, we'll see that our UI appears under the foldout we've created and is ready to use. Let's test it and enter the player mode. Open the friends list, change the friends count value, and see it reflected in the friends list. With this extension, we can check the friends list feature and how it reacts with the UI, how the prefab displays the names, and if there's anything to change. We can also check the pooling system that we've implemented and if it works. Let's change the values. With this test, we can also check some errors like missing characters, and we can investigate them without having to run it on a device. In this case, we will change the prefab we're using to populate the list to another one that supports these characters. This works perfectly. I've created two other scenarios for this project to show you how you could leverage this feature even more. One of the scenarios is very helpful if you are looking to test a game over pop-up. When you test a game, one of the screens you need to check is the game over. And in this case, some of the games are very complicated to lose, others are way easier. But whenever you need to test this screen, after integration, and if it has animation or sounds or maybe different layout for a high score or not a high score, it becomes very time consuming. So I created this simple extension to help trigger the game over either with or without a high score to check this integration. Let's open it in the UI builder and see what we are working with. It has a toggle for the high score and a button to open the window. Of course, it has the title to show what we are testing exactly. Now, let's try it. We will add it to the device simulator extension script, the same way that we did with the other UI. We clone the visual tree of the new UXML on a new visual element. Then we add a method that will trigger the game over event with a boolean for the high score state. This method will be called each time the button is clicked, and the high score will be updated each time the toggle is checked or unchecked. Last thing, as we did previously, we add this visual element to the foldout. And once this is done, we go back to our device simulator and we'll see the new section appearing after we compile. Now let's test it and try the game over when there is high score and where there is no one. Yep, working quite good. The other scenario uses a slide to test the inventory system. When we add it, we can check the particle system that is triggered only once when an item is revealed, without having to reveal the item manually from the hierarchy. I now have done all the tests I wanted to do without even having to build or play the game. This does not mean that I will not do it on a real device at one point, but that already cut the number of iterations I'll have to go through by half at least. And that's how the device simulator can make your life easier. You can test your game and UI on realistic game views and check resolutions, save areas, and try the rotation. You can also simulate the language change, the internet connection drops, and low memory events. You can even add your own custom device to work on. And of course, you can create your own scenarios and extend the device simulator window to make your own tests. Thank you so much for following this session. Hope to see you very soon in the next one. Bye!